Today we're going to talk about normal distribution and its empirical rule. And why do we want to discuss about normal distribution is because normal distribution is one of the most important statistical distributions of data in the field of statistics, and generally it's one of the easiest to understand. So normal distribution is a bell-shaped curve like the one you see right in your screens that is symmetric about a point in the middle, and this point is what we know as the mean of our data. Okay, so normal distribution curve or a bell-shaped curve is vertically symmetrical at its mean. And one of the properties of a normal distribution curve, aside from it being symmetric about a vertical line through the mean of the distribution, is that its mean, median, and mode are equal, right? Because the mode is the most frequently occurring data in our distribution, and that would be represented by the peak of our curve. It is also the median because it is also the middle value of our distribution, right? That's why the property of a normal distribution, or I mean, one of the properties of a normal distribution is that it's symmetric at its mean, and its mean, median, mode are equal. Also, one of the properties of a normal distribution is that the area under the curve that are symmetric about the mean are equal, meaning to say this area here and this area here are equal, right? Because it's symmetric. If I fold this bell-shaped curve that we have here at its middle, at the mean, right, at the vertical line that gives it symmetry, it would be the same. Therefore, whatever the area on my left would also be my area on the right. And the total area of this bell-shaped curve is equal to 1. Now, for a normal distribution, there are two parameters that we should know. One is the mean, because the mean would tell us the middle or where our symmetrical line would be, and also the standard deviation, which is represented by the small case sigma. So x values or data sets that are greater than the mean would be on the right side of our normal distribution. So if your x value is one standard deviation above the mean, then that would be somewhere around here, right? Two standard deviations would be around here, and three standard deviations would be around here. If your x value is lower than the mean, it would be on the left side of your bell-shaped curve. So if your x values are one standard deviation away from the mean or below the mean, then that would be here. Okay, 1, and then 2 standard deviations, 3 standard deviations, right? And we know, after learning about our measures of relative position, that the z-score is essentially the value that tells us how many standard deviations away from the mean are we, right? So the z-score of x's that are one standard deviation away from the mean is essentially just 1. So let me write that down. So the z-score that is one standard deviation away from the mean is 1. The z-score for 2 standard deviations is 2, because there's 2 standard deviation between the mean and that x value, and so on and so forth, right? So this would be 3. Here, this would be a -1, right? The negative sign tells us that it is on the left side or below the mean. This would be z is equals to -2, and this is z equals to -2. 3. Okay? If you have forgotten, the formula for the z-score is equal to the x value minus the mean of the distribution, or the mean of your data set, divided by the standard deviation. This would help you find the z-score of your x value, knowing the parameters that is needed for our normal distribution. But for now, for this video, we would not really be talking about the z-score. What I want to talk about in this video is the empirical rule of normal distribution. Now, knowing how much or how many standard deviations your x value is away from the mean would already tell you how many percentage of the distribution falls within that standard deviation. And that is given to us by the empirical rule. Okay? The empirical rule of a normal distribution, rather, the empirical rule for a normal distribution is approximately, right? Approximately, if your data is one standard deviation above the mean. Okay, let's try to draw a line here. Okay. If your data is one standard deviation above the mean, the percentage of the data within that one standard deviation is 34%. Okay, that's what the empirical rule tells us. Now again, remember that one of the property of a normal distribution is that it is symmetrical, right? So if one standard deviation above the mean is 34% of the distribution, then one standard deviation below the mean, right, is also 34% of the distribution. So essentially, the percentage that is one standard deviation of the mean, right? The data that lie one standard deviation of the mean, that means below and above the mean, is 68% of the data. Okay? So you add the 234%. So within one standard deviation, that is 68% of the data. Now, if your data is from one standard deviation to the second standard deviation, right? That's this area here as well, because again, it is symmetrical. Now, just pardon the drawing. I don't really draw well, but assuming that this is a perfect normal distribution. Between one standard deviation and two standard deviations, that's 13.5% of our data. 13.5% of our data. Okay? So if you're going to add 13.5 and this 34 here, and then you would consider both sides, no? Both sides. If 68% of your data lies within one standard deviation, then the data that lies two standard deviations is 95%, right? This and this is 95% of the data. Okay? That's 95% of the data. Empirical rule also tells us that if the data lies between two standard deviations and three standard deviations, then that percentage of data is 2.35%. 2.35%. So if it's 2.35% on the left side, it's also 2.35% on the right side. So if you're going to look at it, approximately, the data that lie within three standard deviations of the mean, right? That's considering three standard deviations above the mean and three standard deviations below the mean. That's 99.7% of the data. Okay, so that's what empirical rule for a standard, the empirical rule for a normal distribution is. Okay? Again, if your data lies within one standard deviation, then that's roughly 68% of the data. Okay? 68%, 34% of the data is above the mean. Okay? And then 34% of the data is below the mean. Now, if your data lie within two standard deviations, then that's approximately 95%, right? 95%. So, the percentage that is two standard deviations above the mean would be 34% plus 13.5%. That's roughly around 47.5%. That's why 47.5% above the mean plus the 47.5% below the mean. And when you add up together, you would get 95%. Okay? If your data lies within 3 standard deviations of the mean, then that's 99.7% of your data. Okay? 2.35% from the second from the second standard deviation to the third standard deviation. I mean, 2 standard deviations and 3 standard deviation, that's 2.35% of the data. So when you add that up with the 47.5% of the data that is between the mean and and 2 standard deviation, that would give you around 49.85% of your data, which gives you 99.7% of the data that we have here. Okay, and that's what empirical rule for a normal distribution is.